And the third one?
The net forces are zero.
Yep. All right, so think about this. If acceleration is zero, then there's no change in velocity. So you throw the ball in the air at the peak, it's not moving, it stops. And if you're saying the acceleration is also zero, that means the velocity won't change, which means the velocity will stay zero. So you throw the ball up in the air, the ball gets to the peak and stops, hovers midair. That would be the situation if acceleration is zero at the peak. I will contend, I've never experienced this where I throw an object in the air, other than like a helium balloon and just keep going. Throw an object in the air, reaches the peak, and then just hovers. It is not within my realm of experience. If it isn't within the realm of your experience, film it. Post it. Baffle the scientists. So, acceleration at B is what?
Zero.
Nope, not zero. Because if acceleration is zero, that means velocity doesn't change. That's the whole hovering thing. Let's think about it in terms of forces. Once the ball leaves the person's hand, so for the duration of this problem, force diagram, tell me the forces acting on the ball. Do a little checklist here, F down. And remember, no Jedi powers. What are the forces acting on the ball? Or can we eliminate anything?
Weight.
We can.
The weight for the ground.
The weight, are we eliminating weight or weight is included?
Right?
Is weight acting on the ball or not?
Acting on the ball.
Okay. Which way does weight act on the ball?
Go down.
All right, so we have weight acting down and then weight acting up. All right, so weight is done. What about the others? The others?
No.
None of them?
There is none of
All right. Normal force requires contact. Friction requires contact. Tension requires a tight rope or something like that, and there's no mysterious force acting on the ball. That gets rid of other. When the ball is at the peak, how does the force diagram change? Or at what point does the force diagram change?
Will it change at B because it's changing directions?
So how would the force diagram change at B?
The weight would be in it. It would change. Maybe it wouldn't.
I think, Joanna, that was you? Oh, Manal? Somebody said something.
Yeah, I said it wouldn't change.
It wouldn't change. So the weight is always acting down on it. So that's the only force acting on the ball, because we're ignoring air resistance. So at the peak, what's the direction of the acceleration?
Positive.
Downwards?
Yes?
Positive. Positive. More than zero.
Positive. When you're trying to figure out the direction of acceleration, it's always in the direction of the total force. The total force is down the entire time, so acceleration is down the entire time. Or over here, shade in the negative.
I have question.
Yes.
Why acceleration on point A minus. In point A,
So for which one?
in point A,
In going to A?
point A point, yes. Why acceleration is minus? Why not? It's no acceleration and no. It's still in the hand.
No. The problem starts just after ball leaves hand. I deliberately started the problem when
Yeah.
the boy was not touching it. That's why. If we started the problem with the ball in the hand, then there's positive acceleration up to a certain point, then it's zero somewhere and then becomes negative. But I started the problem after it's already left the hand. Other questions?
Wait, why is velocity negative again from B to D?
Velocity cares about the direction of movement. So from A to B, it's going up. From B to D, it's going down.
Okay.
And so, because that's positive. And remember, that's instantaneous velocity. If I said average velocity, that's something very different. Average velocity would be the same as the displacement. But this is instantaneous velocity. It's falling from B to D.
So you said acceleration has to do with the force.
Yes.
Okay, all right, I see why it's like that.
Okay. Other questions at this point? So we have three different ways of expressing this. I guess there's 5 ways total. If you look through everything I've ever done, there's 5 ways I've done it. I've got these 3. There's also, it's very similar to this, except I say, where's the position greater than 0? And then I give you a blank space to write in that. Whereas it equal to 0, give you a blank space to say not applicable. And then in the PowerPoint, I also do it using words. Just be careful if you're going to write it in English as opposed to some shorthand notation. I have had some students, if they wanted to express velocity is positive from A to B, and they'll write from A to B. And now I have to guess, do they mean to include A and B or not? If you think about it from this point of view, I got 1, 2, 3, 4, 5, 6, 7 different regions of time. And from A to B, potentially it's just one of those 7. So if you're going to write it out in words, just make sure you are very clear whether it includes the endpoints or not. All right, let's do a test level problem. Some of the early tests, this was a test level problem, but then I started getting more sophisticated. Much to the students' delight, I'm sure. Better marker. A flexible wall. So I'm going to have something run into it. The wall's going to flex a little bit and then bounce back.
A, B, C, D, E, F, G.
All right. Problem starts with box moving to right. To the right. I'm going to make to the right positive. So A time problem starts. B, first time box hits friction section. So from here to here, there's friction. Now I'm going to use shorthand notation to represent the fact that there is friction. I'm going to put a little mu here. It's a Greek letter mu. There's something that we'll get to in chapter 4 or 5 called the coefficient of friction, and the mu is the symbol for that. So if I write mu is not 0, that's telling you that there is friction there. I'm also, for the square bracket here, I'm indicating that B has friction, D does not. This is a little bit darker. Yeah, okay. Time ball is at location of eventual stopping point. So time C, it's still moving to the right, but it's going to eventually stop at time I. D, first time just after friction section. E is, should I be consistent or just wing it? Yeah, I'll wing it. So E is last time before touching wall. F, time of maximum wall displacement. I'll give a visual for that in just a second. G, first time after wall, not touching wall. So E and G are the same location. H, last time, or the moment before, that's probably better wording. So last time before touching wall, instead of last time, I'll write moment just before friction. And I, the exact moment box stops. Just write that down. And
What did G say?
G is first time after wall, not touching wall. Started a little bit over to the left, but there it is. Let's see, is that in screen? All right. All right, so let's do this as a group. So let's do the setup like this. It's more writing up front. All right, and I will tell you that on the test level problem, no two of these rows will be identical. I mean, there might be, in a couple, those might be the same, or those might be the same, but the entire rows will not be the same. And I'm telling you this because if I see an entire row identical to another one, I'll give you the credit for the one that gives you more points, but I'll give you no credit for the other one that duplicates. Because it usually comes across as, for instance, position and displacement comes across as, I can't remember which one's which, I'll just put down the same thing for both of them and hope for the best. All right, so let's start out with, oh, I didn't tell you where 0 is. So it stops, and this is what we'll define as the origin, is at time I. Or the position of the box at time I is the origin. All right. So let's start out with position. Where is position equal to 0?
A.
Not A. What is position dependent on?
The origin,
Yes, and where's that?
I.
All right, so position is 0 at I. Is it 0 at any other time?
At C.
Yes. So once we've established zeros, because you can't go from positive to negative without going through zeros, so 0 is rather key here. All right, so what about before C? Is that positive or negative? Yeah. Yeah, setting up our, I said to the right is positive, so here's my number line here, and the origin is at I, so there's basically my setup right there. Anything to the right is positive, anything to the left is negative. Those are negative. And then between C and I? So I could write, doing it slightly differently. It's positive from C to I, not including them. It's 0 at C and I, and it's negative from A, including, to C. I often find it's helpful to identify, if you can identify where 0 is, that usually helps out a great deal, at least for the first 3. Questions about how we got positioned like this? All right, displacement. Where's displacement 0? Now's the time to do. So, where's displacement 0?
The starting point.
Yes. Which is?
A.
Yeah. That's why I pointed to you, Naveen. That's what you said last time. You were just ahead of your time. All right, so, and what about the rest of it? Just basically we're shifting our coordinate system there. my displacement is positive, not including A, until the very end. And then it's 0 at A and never negative.
Is that overall displacement?
Yes, it is.
If it was instantaneous, would it be negative going from E to back to C?
It would be negative going from F to I.
Okay.
Yeah, so the box is traveling this way and then that way. It's still traveling in a straight line, I just, have difficulty of how to display the numbers. But on the test-like problem, this will be overall displacement, this will be instantaneous velocity, instantaneous acceleration.
Are we gonna be in, is this instantaneous? No.
One more time?
Is this instantaneous or no? That's not,
This is overall,
okay.
these will be instantaneous. If you, on the test, you decide to display it like this, you do need to express not applicable, because otherwise it looks like you might have just forgotten to do it. So you need to somehow give some indication that it doesn't, it's not here at all. It's never negative. All right, velocity. Oh, let's talk about what's happening here at the wall. All right, so let's pretend this is my wall right here, and here's the box. So it's cruising along, starts at time A, hits the friction section from B to D, and then it touches the wall, or just before it touches the wall is E. It then hits the wall, it flexes, that's point F, and then bounces back, and just after leaving the wall, that's time G, and then it's bouncing backwards. So E is just before it hits the wall, F is when the maximum deflection, and then it bounces back. G is just after touching the wall. All right, so velocity. Where's velocity 0?
On F,
You said A? The problem starts with the box moving to the right. All right, it is stopped at F, because that's the point where it turns around. So, is it stopped anywhere else? Yes. So once we've established our zeros, now it's a question of what's happening in between. So what about before F?
G.
Positive.
Oh,
I'll look for positive, negative, or 0.
Positive.
Yes. Because it's moving to the right from the beginning of the problem. It eventually stops. And then what happens?
It's negative.
All right, and so now the tricky one. I comment on class participation here. Everyone in here is going to make plenty of mistakes. I'm just flashing back to when I was a student. I always hated to make a mistake publicly, and that was to my detriment. I think as soon as you can get over the fear of looking like you don't know anything, the better it will be. So just go for it. Acceleration. All right, can we establish any place where it's positive, negative, or 0? And it might be easiest to think about it in terms of forces.
B to D would be negative,
Why?
because it's the friction zone
Which way is friction acting on it from B to
to
D?
the right.
So friction's acting on it to the right as it goes? That's what you said?
No, to the left. Yes,
It's one of those two.
it's
Your-
left,
your-
it's left.
Your final answer? All right. So as the box is moving this way, friction opposes that, so friction's acting the negative direction. So acceleration is negative from B to D. All right, so I've got between B and D. What about at B and D?
Wouldn't E be included in that?
The friction ends here. Oh, you're saying E should be negative? Let's get to that in just a second.
Including B, not including B.
Okay. All right, so Taylor, I think it is, you're the one who said E. What's your thinking on E?
Because it hasn't got to F yet, and then F would be where it becomes positive.
All right, so it's, at F, it is positive. Why is it positive here?
Because it changes directions.
Changing direction doesn't always mean it's positive. Once it touches the wall, as soon as it touches the wall, what's the direction of the net force acting on the box? So the wall was pushing on it that way?
No, it's negative. It hits the wall and then it bounces back.
Big shot.
Yeah. So there's no friction here actually. But what is the force the wall exerts on the box?
Zero.
Normal force?
Going for the name of the force.
Normal force.
There we go. Third time with confidence. Yeah, it's a normal force, because as soon as it pushes against it, there's a normal force involved.
Plus D zero. Why is D zero?
What forces are acting on it at point D? Because D is after the friction section.
Oh, okay. So it stops.
Yeah, so the friction ends just before time D. So at time D, what are the forces acting on it? Let's say when the box is here, doesn't matter which way it's going. What are the forces acting on the box at this point?
Weight and normal force?
Normal.
Yep. So I have weight acting down, I have normal force acting up. There's no other, there's no mystery. The only time that there might be a mysterious force is how A got started to begin with, but not necessarily. It is possible that A came into existence already moving to the right. Definitely there's no ropes involved, and there's no friction because friction ends here. So I have only two forces. None of them are horizontal. So there are no forces acting on it horizontally. In other words, this is just going to keep, from here to here, it's just going to keep doing whatever it's doing. Inertia. It requires a force to make it change its motion. So that's why D is zero, because it's after the friction section. And it's going to stay that way. Until what point? At E, is it still zero, or at that point does it change?
It
It was
changes.
from 0
Why is it still zero at E?
because it didn't touch the wall.
Right. E, before touching wall. All right, so now it hits the wall. Why positive?
Because it starts going. So it hits the wall, and then it bounces back,
Right.
and it continues to go
It,
to the.
as soon as it touches the wall, it continues to go to the right, and then it bounces back, shoots off to the left.
Is F also zero?
Negative zero, positive.
It'd be negative, zero, positive? Nope. Again, think of the forces. When it's touching the wall here, so I got wall, I have box. What are the forces acting on the box? I'll spoil two of them to you for you. I have weight acting down, and I have a normal force acting up.
Friction back?
Nope, no friction involved at this point.
tension because of the wall?
Tension requires a rope or something pulling on it. Is the wall pulling on the box?
Would it be other?
Not an other, because we know exactly what's causing the force.
Oh,
Well, let's go down our list here. Weight is between the box and the ground. That's done. There's no other because I haven't introduced any hand of God or anything like that. There's no rope or chain or anything pulling on it. Friction because it's a board problem, so I can declare the section without friction.
There's normal force between the wall in the box and the ground in the box.
Yes, there's two different normal forces acting on it. This is from the ground. Which way is the wall exerting the force on it?
Backwards.
All right, so it's gotten left and right. It's one of those two.
Left.
Because the box is pushing on it.
Okay.
Sorry. I thought I got all the dog hair out, but I don't think I did. So the wall is pushing, the ground is pushing up on it, and the wall is pushing to the left on it. Now the weight and the normal force presumably are balancing each other out, so there's no force, the net force up and down is zero. But there is this force right here. Doing what? Oh, sorry, let me reword that. What's the direction of the acceleration? Okay, I think someone just said to the left. Yeah, because that's the net force is right there. The box is pushing on it, so it is negative while it's touching the wall. Now, in the first region here, from between E and F, when the velocity is positive and acceleration is negative, it's slowing down.